ebgp multi-hop. In some cases, a Cisco router can run ebgp with a third-party router that does not allow direct connection of the two external peers. So to achieve the connection, you can use ebgp multi-hop. The ebgp multi-hop allows a neighbor connection between two external peers that do not have direct connection. This is only applicable for ebgp, not for iBGP. So this example here. I have created almost the same topology in DNS3 here, and we're going to demonstrate this, how or configure this. So let me go to, actually it's gonna be R1 and R2. So this here. So I have already configured the interfaces. So in R1 I have configured G0/0 and configured that IP address. And on R2 I configured same interface and this IP address. And of course I have kind of mimic this by creating a loopback on R2. So loopback is actually /24. Yes. So let's go ahead and configure ebgp multi-hop. So I have created a steps here actually, because it says here uh, you should configure an IGP or static routing to allow the neighbors without connection to reach each other. So this is what I'm going to do first. Basically configure an IGP, in this case ospf, so that R1 can reach the loopback on R2. Okay, so let me go ahead and do that. Just copy and paste. Go to R2. Done. So now if I check R1, well, we have to wait for ospf to come up. Just give it a few seconds. I can see R2 and I can ping it. Show ospf interface brief. Okay, wait. It's in wait state. I'm not gonna wait for that time. I'm going to go ahead and configure this here. So from R1, so our neighbor is the loopback on R1, loopback IP address. So R1, oh, so it looks like ospf has come up. Yeah. So R1 is learning this loopback address via ospf, and this is the next stop. So let's configure. We can now configure BGP. So let me just do that first and do the same on R1, on R2. Oops. Okay, so we know that R1. So this will not come up because this loopback here is not in the same subnet that R1 is in. So basically we need to configure ebgp multi-hop in this case, because I have another command here that we can check or we can use. Oh, we cannot see it because it doesn't come up yet. Yeah, so idle. Doesn't BGP. Oh, there we go. Yeah, it doesn't show the TTL. Okay, I think because this is not it's not established yet. So I'm going to go ahead and configure this uh, on R1 so that um, BGP will establish, because it will not establish unless you configure ebgp multi-hub. Save the config. Oh, now it has come up. BGP has come up. So if we do the same command, we see that the TTL is set to 0 to 2, the outgoing TTL. So that caused the the eBGP external BGP to come up. Let me do the same. Let me do this command on R1. Okay, looks good. Save the config, and this command as well. Yeah, does come up. Yes, and we can also, what else? eBGP. Yeah, nothing. We're not advertising any networks in BGP, so that's fine. So now let's configure ebgp multi-hop to achieve load balancing. So I have another topology here, which is this is also the topology in this website. So almost copied the IP. I mean, copied the IP addresses, of course. So same thing. I have also already configured the IP addressing for the interfaces. So on R4, I mean on R3, that's the IP addresses. This is the IP addresses on R4. Okay, so yeah, so let me just show this to you. So G00 has an IP address of this, and G01 has an IP address of this on R3, and this is the IP addresses on R4. Okay, and of course we are using loopback here to establish our BGP neighborship between the two routers. So as same as before, we need to configure an IGP or static routes to provide connectivity between the devices or between the source addresses. So in this case, the the loopback addresses. So between the source, let me say source addresses. Yeah. So I'm going to configure these static routes on R3. Just copy paste. So this is the loopback on R4. Let me is here the loopback IP address. yeah, the IP address, and of course the subnet. So let me configure that static route, and let me configure this static route on R. Let me just close this on R4. Done. So yeah, we are going to use loopback addresses of the indirectly connected peer and the multi-homing command to increase the TTL. So in this case, we are increasing TTL to 2. This is because eBGP routers use a TTL of 1 for their BGP packets. So by default, eBGP routers use a TTL of 1. Okay, so let me just check this here. This example illustrates the use of loopback interfaces, update source, yeah, same thing. The example is a workaround in order to achieve load balancing between the two eBGP speakers over parallel serial links. So this topology is using serial links. In our case, we are using Ethernet. In normal situations, BGP picks one of the lines on which to send packets, and load balancing does not happen. With the introduction of loopback interfaces, the next hop for eBGP is the loopback interface. So you use static routes or an IGP to introduce two equal cost paths to reach the destination. RTA has two choices to reach next hop. Okay. Okay, so basically we are using loopback interfaces to achieve load balancing between these connections. So going to configure, just copy and paste this configuration. So yeah, so from to R3. So here are my local AS is 100, remote is 200 using the ebgp multi-hub command, and the TTL, I set the TTL to 2, and I'm using loopback address as the source address, and advertising this network. And basically the same commands on almost the same commands on R4, right? Let me actually go to R4 and just show this here. So local AS is 200, remote is 100, which is what we have in our topology. And here we are using the same loopback address. And here, eBGP, yeah, maximum hop count. So this is actually maximum hop count. So we are setting it to 2. Okay, looks like BGP has come up. So by the way, when we don't set the hop count, by default in this particular iOS, the hop count is set to 255 by default. So it looks like our BGP has come up, so we can do this command here. Let me go to R3. Yeah, BGP has come up. Check if, yeah, I'm advertising this route here into BGP. So basically next step is myself, so I'm originating that route. Okay, and that route is the loopback address, right? Yeah, it's assigned to the loopback address. Loopback interface. Okay, so let me just do this command here. So yeah, the outgoing TTL is 2. That's why our eBGP neighborship is working as expected. And we are using loopback to achieve loop back as the source address to achieve load balancing between the two connections here. Okay, so yeah, I think we're done. That's it for ebgp multi-hop. I'm going to add add the link of this website in the description of this video. So, yep, thanks for watching. We'll see you next time.